Hello. In this video I will be talking about how you do a simple titration and specifically how you use a burette in the proper way. First of all, let's talk about the burette. It is simply a long tube with milliliters marked off on the glass and tenths of a milliliter in between. And this particular one goes from 0 at the top to 50 at the bottom. Now, that's a little odd because you're starting at the top and working down. That's an important idea. I'll get to that in a few minutes. Also, there's a stopcock at the bottom that allows the liquid in here to not flow through, or if you open it up, in other words, point it straight up and down, then the liquid will flow through. So let's get the burette ready to do the titration. First thing we're going to do is add titrant to the burette. Usually the titrant is going to be sodium hydroxide solution. That is mostly water, but with some sodium hydroxide salt in it. In this case, we're using 0.0012 molar sodium hydroxide. Titrants can be lots of other things, but typically it's sodium hydroxide. And I'm just going to add a small amount of sodium hydroxide to the burette. And oftentimes we'll use a funnel to do this, unless you're very sure-handed. I've only put a little bit in, just enough to basically reach up to the numbers here. But I've left the stopcock closed, obviously, because I don't want it right at the bottom. And what I'm going to do is just rinse the burette a little bit by turning it, getting the titrant all in contact with the glass so that any contaminants or any other solution that might have been there will get washed out. And then I'll just run it through the stopcock into the sink. Drain it that way. Then I will attach it to the ring stand using a handy double burette clamp, which I'll show you what it is. This comes off the ring stand, and it's just a easy way of attaching a burette to the ring stand. By the way, this solution in here is an unknown acid, again dissolved in water, so it's an aqueous solution. Both sodium hydroxide will be aqueous and the acidic solution down here will be aqueous. And we want to titrate this to get an idea of how much acid actually is there in the solution. So I'm going to move that aside for the moment because I'm going to fill my burette. This tip down here at the bottom has some air in it. Once you start draining the liquid out, that air will disappear, and that will change the volume that was up here without changing the volume that's down below. So we want to get rid of that air before we start titrating. So just bring it out a little bit. Now you'll notice that the tip is full of the titrant portion. So I'm going to refill my burette. Here's an important question. Do you need to fill the burette so that it's exactly at the 0 line, as I have done? A lot of people have trouble getting it exactly at the 0 line. By the way, you want that little smiley surface of the liquid called the meniscus. You want the bottom of that to be right at the line. One thing to notice is as you're reading a burette, the angle of your eye makes a big difference. So if I hold the camera down low and look up at the meniscus this way, it appears to be one reading. But if I move the camera and look down at the meniscus from a different angle, it looks like the reading is a somewhat different reading. Ideally, you want to keep your eye so that it's directly perpendicular to the meniscus. So we'll hold it like that. Does it have to be 0? And the answer is no, it doesn't. As long as you know what the beginning point is, you can write that down and remember it. In fact, I'm going to write down 0 milliliters as my starting point. Now, it's easier to do the calculations if you start right at 0, but it's not necessary as long as you know what your initial volume was on the burette. Okay. Notice I put the cap back on the bottle, as you should always do. Anytime you use a reagent, always put the cap back on immediately. Now I'm going to take my unknown acid, which, by the way, I pipetted 20 milliliters of it into this container before I turn on the video. And leave it under there. I'm going to adjust the height of my burette so it's just a little bit above the container of unknown acid. Now I'm going to take a small amount of phenolphthalein in solution. So I'm just going to take a few drops of it and add them right into the material down here. Put the top back on it. And now I'm ready to do my titration. Notice I'm swirling the liquid a little bit down here just to make sure that that phenolphthalein gets all mixed up in there. Why do we add that phenolphthalein, and why did I not care how much I added? I just added a few drops so that I wasn't worrying about how much. Well, phenolphthalein is a material that, as long as it's in an acid solution, which it is now, it will be colorless. But as soon as that solution becomes basic, in other words, the amount of sodium hydroxide exceeds the amount of the acid that was originally there, then it will turn pink. And so what I want to do is just add enough sodium hydroxide that it just barely turns pink. At that point, I know that I will have added the same number of moles of sodium hydroxide from here that I had moles of the unknown acid to begin with. So what I'm going to do is just start by turning the stopcock one way or the other, doesn't matter which way, and start to add some. But again, as I add some sodium hydroxide here, you'll notice that pink color appears in the unknown acid solution, but then disappears immediately. So why is that pink color appearing? Because in the drops, in the parts where the sodium hydroxide is added directly in, there's enough sodium hydroxide in there to turn the phenolphthalein pink. But then it reacts with the acid that's totally surrounding it in the solution and goes back to being colorless again. So we'll keep on adding. At this point, I can add quite a bit at a time, and it just turns pink and then disappears immediately. If we reach a point where it takes a little bit more time for that pink color to disappear, then we might know that we're getting close to the end point. At this point, I've added about 8 milliliters. So what I'm going to do at this point is start to drip in the sodium hydroxide drop by drop. Keep on swirling it. And notice that the color keeps disappearing. I'm going to actually slow it down a little bit because it's taking a little bit longer for the pink color to disappear. So I want to add it so it just goes drop, drop, drop. That way, if the pink color doesn't disappear, I can catch it and turn off the stopcock and I'll be done with titration. Again, notice that the pink color is disappearing every time a drop hits. It forms a pink color, but then it disappears again very quickly. I'm swirling it continuously because I want it to completely be mixed up each time a drop hits. And there we go. We've reached the end point. So, now that we've reached the end point, let's talk about how you read the burette. There's the end point. Notice that the meniscus is a little bit below halfway between the 15 and the 16. So how should we read that? Should we read that as 16 point something, or should we read it as 15 point something? Obviously, since the numbers are increasing as you go down, that's more than 15 but less than 16. So we should read that, the bottom of the meniscus, as 15.7. 15.7 milliliters to the bottom of the meniscus. Now notice the appearance of the 15 and 16 lines. If I move my eye out of alignment too high, both the 15 and the 16 appear to be curved. If I move down the other way too far, they curve the other direction. But if I have my eye in exactly the right position, the 15 and 16 lines appear to be straight across. And notice that if I'm in the wrong angle, look at that 15 line, you can see that there's sort of an oval shape. The back of the glass and the front of the glass form an oval shape. Same with the 16 line. But if I hold it in the exact right position, they both become straight across. That's the way that you know you're reading it in exactly perpendicular. So the reading is 15.7. And that's the final volume. Since the initial volume was 0, we know that the amount we added was 15.7. If the initial volume had been something else, like let's say 0.3, we would take the 15.7 minus the 0.3, and we'd get 15.4. But in this case, since we started at 0, we will read that as the total added at that point is 15.7. Thank you.